Hello guys, today we are going to see how to analyze two-factorial experiment by using SPSS in case of more than one dependent variable. Last time I showed you already how to analyze two-factorial experiment with one variable, and today we are going to see what if the variable is more than one. We can start by writing our variables here on the variable view page. So we can start writing our variables. First we can write our replication, because whenever we do experiment we have replication to reduce error. Then our factors are salts and silicon. And our variables are, we can use these variables LF, ET, ACE, LF, ET, and we will continue writing our the rest of our variables, dependent variables, but first we have to label the values of our factors. In this case, salt and silicon are our two factors, so we need to label them before we go ahead and write our the rest of our variables. We have four different salt labels in this experiment. We can label them. The value 1 will represent 0.6 decisiemens per meter. This is the measurement, the unit for measuring salt's level of salt. And 2 will represent 2 decisiemens per meter odd, and 3 will represent 3.2 decisiemens per meter. Decimals per meter. 4 will represent 4.8 decimals per meter. Then we say okay. Then for silicon also we'll write the same way. 1 represents 12 milligram per liter. So we can continue writing like this. Then after we're done with writing every variables and their label and everything, we go to the data view. In this on this page we'll find our variables here on top of the row. Then we start representing them. For example, for our replication, the replication is 3, so we can write 1 2 3 1 2 3 1 2 3 1 2 3. It goes like this. And for salt, as I said, we have 4 levels of salt. We can start writing 1 for salt, 1 1 1 1 1 1 to 9. I mean, make sure that every salt level is replicated 3 times, because the replication is every level is supposed to be replicated 3 times because our replication is 3. And for silicon we have 3 levels, as I told you. 1 2 1. Okay, 1 1 1 2 2 2 3 3 3. Why am I writing it like this? Because to make sure that every salt level is within each silicon level. For example, 1 1 1 1 every the first level of salt is, for example, in each level of silicon, just to make sure that every level of salt is in each level of silicon. That's the point, the whole point. So I continue writing the salts 9 times again, the second one, then the third one 9 times, I will continue like this. Then I finished writing, representing each factors and replication. Then I will write the value of each variables here. I have a lot of variables in this case, so I will write each variable's value here. I will bring it from here, so I will copy and paste it. So here is how it looks after I wrote everything: replication, salt, silicon, each the value of my different variables, more than one variables in this case. So I'm gonna analyze it by using general linear model. In this case, as I told you last time, as I showed you last time, when we analyze two-factorial experiment with one variable, we use this one, univariate. For now, since we're gonna analyze more than one variables once at a time, so I am going to use this multivariate. So our dependent variables are these ones, and our fixed variable or factors are this one, to salt and silicon. I showed them. Then we can go to the plot. We can put silicon to the horizontal axis, salt to the separate axis, add, continue, post hoc, we can choose both of them, and LCD, then can test, continue. Okay, we don't need this. Okay, this one, descriptive and homogeneity tests. We need homogeneity test and descriptive. The significant level is 0.05. This is important. So when we analyze it, this is where our reference, below which we call it significant, but if it is if it's the number is bigger than 0.05, it's non-significant. So we click continue, then we say okay, it's analyzing already. Yeah, this is our results. We can go to the test between subjects effect, test of between subject effect. We can go ahead and see it. We can come here and see whether our dependent variables are significant. Okay, when we see salt, under salt level, LF is non-significant. It's not significantly affected by the different salt levels. this one is